Today we are going to do Algebra Section 1.2, but before we do, being that we are still in the review chapter, please consult this problem first. Now, take a look at this, okay? These are problems I got from the homework section of this section. Now, look at all this. Do you know how to do this stuff? I mean, especially the problems that look more longer and have more to it. Can you do this in your head? That is, can you do this in your sleep, really? Because if the answer is yes, then you can skip this section and this video, okay? If the answer is you're not that sure, maybe most of it, then you need to finish this section. And then, and my point is, you need to be extremely good at doing this stuff, okay? Be able to do it in your sleep. And so, or do it with your eyes closed, whatever the saying goes. So, so please continue this video if you don't think that you can do this stuff extremely well, okay? But if you can, then please skip this section. There's no reason to waste your time doing the review, and maybe go to the next section or the next chapter. The next thing I want to show you is an algebra chart that I downloaded online. Now you notice that there are various formulas in this chart. Today we're going to focus on one part of it, the exponent properties, because that's mostly what we'll be doing today. But what I want you to do is, well, these formulas are also in your book. As we go along, we will review them. But what I want you to do is create a chart like this yourself, either by using computer and doing some screenshots and move it around, editing, or just write it down by hand. Either way is fine. Just make sure if you write it down by hand, make sure you didn't make a mistake, okay? So then, but once you write it down, this will be your cheat sheet, okay? That way, anytime you do algebra, you have the cheat sheet right next to you, and you can refer to it, and it makes everything so much easier. So that is. And as time goes on, you might be more familiar with some of the formulas and don't need them anymore. Then you move it to a second page of your cheat sheet, and then so that all the stuff on the first page are the most important ones that make it easier for you to find. And as time goes on, if you find that you need some of the stuff in the second page, then move it back to the first page. All right, so please construct your own cheat sheet from this point on of anything, okay? Anything that you find yourself needing to look up. Doesn't matter what it is, and because this is all your personal cheat sheet. So if you say if you have trouble with some easier formulas but have no trouble memorizing some complicated formula, then put the complicated one in the second page and then the easy one on the first page. Just whatever it works for you. So okay, now having said that, let's begin. So first, let's go to page 24, the product rule. When you have two bunches algebraic expressions multiplied together, such as you can see, x cubed times x fourth, that just means how many do you have total that's multiplied together. Then as a result, when you do exponents, you add them. When you multiplication of two expressions translates into addition of the exponents. If the base are the same, that is so here's the first rule, that is am times, excuse me. So the am times an is the same as a to the power m plus n. That is, but that only true if both bases are a. If it's some other number, then that's not going to work. But as long as they're the same, then you can just add up the exponents, making things much easier. For example, let's see the example here. You have 2 to the power 3 times 2 to the power 4. That's the same as 2 to the power 7, okay? Let's see, so example 1, please do example 1 as part of your homework, where you have several quick problems. In fact, most of the problems in this section are quite quick. Next, let's consider the quotient rule. For example, let's look at the example right here in your book. We are on page, let's see, what is this, 25. You have a quick example where y to the power 9th is divided by y to the power 5. What does that mean? well, that means you're just going to cancel out 5 of them and end up with 4 of them. As a result, the quotient rule states that when you do division of 2 things that are the same, with the same base, both are a, all you have to do is do subtraction of the exponent. So with that, please do example 2 on the next page as part of your homework. As you can see, for example, part A, you have 14 on top and 9 on the bottom. The answer is just 14 minus 9, and everything else works basically the same way. So next, let's look at the power rule. The power rule then, it expresses the, we are now on page 26. The power rule, which states that if you have some function, something that's raised to its own power, then you have 2 powers, okay? Which can look confusing when you think about what that means. For example, if you have x2, x squared raised to the power 3, that means imagine that what's in the parentheses is being raised to the power 3. So x squared raised to the power 3 equals to, you write down 3 of them. Okay, because that's what 2 power 3 means. You have 3 copies of the same thing. And what is this thing? The thing is x squared. So the whole thing added by this rule right here, when you multiply, you add up the exponents, right? The first rule. And therefore, this equal to x to the power 6, which is the same as x to the power 2 times 3. So as a result, that gives us this thing called the power rule, I think, which states that a to the power m and then raise it to the power n, like this case right here, that will give you a to the power m times n. Okay, and do not confuse this one with this one. This one is these 2 things multiplied together, whereas this one is one thing, okay, being raised to the nth power. So you can visualize it as this. Okay, this, what's in here is going to repeat itself n times, and that when that happens, then you multiply it together. Now, with that, please do example 3 as part of your homework. And let's move on to the next page. We're now on page 27. Where we're going to consider the 0 exponent. Now, what does it mean when the exponent is 0? Well, we consider the quotient rule to come up with a reasonable explanation of it. For example, let's look at your book where it says we have, let me see, give me a second. So let's look at the example in your book. Okay, we have t over 8, t to the power 8 over t to the power 8. That would, of course, give us 1, but t to the power 8 by the quotient rule, that means that you subtract the top by the bottom, which happens to be the same at this case, which means that the result will be t to the power 0. See, so because of that, then we define anything to the power 0 to be equal to 1. With the exception of 0 to the power 0. We don't know what that is, but we'll ignore that for now. Okay, and so the next rule, exponent rule, that comes from the quotient rule, that will be defined as anything to the power 0 will be equal to 1 for our class. And we don't care about 0 to the power 0. Okay, that's of no concern to us. So let's look at example 4. As please do example 4 as part of your homework, where you notice that your problems now are getting more and more complicated, but you use the same principle at each step. We will do the whatever this is called. I already forgot it. This is whatever. And the point is, we'll use various rules as needed. And yeah, for example, please do that as part of your homework. Okay, example 4. Now next, let's. The reason I'm not going to go into details is because this is a review class, and also because I think the book gives you a very clear explanation of how to do it, so you shouldn't have any problems. So next, let's look at the next page. We are now on page 28, where we consider, what is this? Negative exponents. Yeah, so the negative exponents refers to something that is on the bottom of the story. That is, for example, as you see in your book's example, let's say you have h3 divided by h5. 3 is on top and 5 is on the bottom. And now by the quotient rule, then you will have 3 minus 5. You end up with h minus 2. See, here's our quotient rule. And what does that mean? That would mean that, so it means that h minus 2 is the same as 1 over h squared. And that is the rule that we're going to follow, which means, let's see, where is it? That is, from the quotient rule, we also come up with this rule, which is a to the power negative n. If you have a negative power, that's the same as a to the power n. So that comes directly from here. Okay, that and all these rules, you just have to well, keep practicing them in the examples until they become part of your inner being. That's the only way you can succeed in algebra or any math beyond algebra. Okay, all this stuff are extremely important. And I don't mean all of algebra is extremely important for later. I'm specifically referring to this chapter 1 and a little bit of chapter 2, where you need to know how to handle equations. So please do example 5 as part of your homework and pay very careful and make sure that you get every single thing right, okay? And more importantly, it would be good if you can do this stuff. Once you get familiar with this, then you should be able to do it quickly. All the stuff can practice, try to see if you can do it all in your head. And I don't mean not write anything down. I just mean that everything, you just go through each formula like you know it, like the back of your hand, and don't even have to refer to it, is what I mean by do it in your head, and just add or subtract or multiply and kick all the answers out as quickly as you can. Okay, and that's what also makes it fun. And the same as example 6, more practice problems. And if you do more of these things, there's a good chance that you can get extremely proficient at it. If after going through all the work, and you find yourself not really getting that much better, that is okay. Because you can just look it up how to do it, but at least give it a solid try, okay, and see how good you can get. That is the fun of doing algebra. So next, let's find the power. Okay, the next thing is situation, is where we have a situation where we have p, something that's multiplied together, that's raised to some power, such as this example on the following page. Okay, we'll just look at it. Now, you notice that this thing is being raised to that power, right? And then what does that mean? It just repeat the whole thing 3 times, which means repeating each one 3 times, right? Everything in the parentheses get repeated. The amount of power that it says in this case is 3. So that's the same as repeating individually 3 times. And that's where we get this formula. That is, if you have 2 things that's being multiplied together, say, what is this called? AB? All right. AB to the power n, that is the same as each one being raised. And that is due to the definition of the power. Power means raise everything, means repeat multiplying the thing inside that many times. And that end up being repeating each one and multiply everything together. Okay, that is, okay. So next, that's example 7. Please do example 7 as part of your homework. Now you notice that this section seems to have a ton of homework. Like if you add it all up, you're probably looking at 40, 50 problems, and that's just in the examples. But in reality, each one of them should take very little time to do. So the whole thing isn't as hard as it looks. No. But as long as you go by the principles, and here are the principles. Now, if you do make a mistake, then the first thing you should do is double check. Did you use the wrong principle? That is, did you confuse this thing with that thing? Make sure that you look at it and know which one are we talking about. Are we being multiplied together, or the same thing being repeated n times? And once you notice that, then it's easy to find your mistake, and then keep going until you get single thing right. Now next, the power of a quotient. The power of a quotient doesn't change much. Okay, that is the quotient. Then, if you have where's the example for it? All right, we will for example look at this example right here. Now, if you have some kind of this is on the page. well, whatever page this is close by. Now, say if you have this particular function, right? You have the whole thing is a quotient, is f squared over e squared, and it's being raised to its power 7. What does that mean? You just raise each one, okay, to the power 7, which means multiply. You're following this rule. Let's see, this rule right here, but for both top and bottom, and you're also following this rule. These two rules are being applied together, which means that the end which gives us the following formula. That is, if you have which two, doesn't matter, we'll write it in a new line. So if we have a over b, both raised to the power n, that will equals to a to the power n over b to the power n. Now, notice that all these formulas, you need to memorize them. And not just memorize them, but to know them and with the inner fiber of your being. Okay, that's the only way to succeed in algebra and beyond. So that's the quotient rule. Okay, so please do example 8 as part of your homework, and then again example 9, the same thing, where you multiply various stuff together and then apply these rules. Sometimes you have to apply more than one rule at a time. The idea is to follow the principles and do one step at a time. And your book will give you very clear instructions on how to do this. So remember, to do your homework, what you do is you try the problem itself, and if you can't get to the right answer, then look at what the book says to help you get a clue. And so that's that. And now we have come to page 33, the scientific notation. Now, the scientific notation on we're now on page 33, is the concept that if you're given a number, let's make up something, say 27, okay? Say the number 27, I can write it as 2.7 times 10. That is why, because I can move, the decimal point is right here, which we don't normally write it down for 27, but it's here. We can move it over one spot and then to that direction, which reduces the number to 2.7, but then we can multiply it by the number 10, which will be the same number. And that's where the scientific notation concept is based on. Now, let's say what if we have 270? Then that would be still equal 2.7 times 100, okay? Which we will write 100 as 10 to the power 2. Well, what the 10 to the power 2, what that means is we actually moved the decimal point 2 places. So for a giant number, the principle doesn't change. For example, here's a number, okay? That's 2 million something. And the decimal point is after 8, so we move it all the way up here, so it becomes 2.7 something, and then multiply it by 10 to the power 6. Then, because you have moved it 6 places, you get 6 zeros, and so you multiply it by 10 to the power 6, and then you get a number that is, this is the scientific notation, which has one number here, okay? That's between 1 and 9. If it's more than that, you will move the decimal point and accordingly. And similarly, let's look at this. And if you consider a decimal point, let's say we have the number 0.27, let's say, okay? Now, how do you write this at a scientific notation? That would be equal to 2.7. We move the decimal point this way, okay, onto the other side. So we increase the value 10 times. But what we're going to do is we're going to multiply it by 1 over 10, which is another way of saying that is 10 to the power minus 1. As we have mentioned before, the minus exponent, where is it? Yeah, the negative exponent is the same as 1 over the number. All right, so we're going to write it down as 10 to the 1 over 10, which then equals to this number. Now, in general, if you have something with a ton of zeros, the principle stands exactly the same as you can see in your book here. We have Okay, we have a ton of zeros. So we're going to move it to the other side until the 4 becomes the first number. It becomes 4.7. To do that, we're going to move 13 places. Okay, so you move that thing 13 places, and then the answer of that number with a bunch of zeros, you write it as 4.7 times 10 to the power negative 13. That means the actual number is you notice there is a negative value, which means this is actually a decimal point, an extremely small one. So you write it this way. If you were to change from this back to here, then you write down 4.7 and then move the decimal point all the way to 13 places, okay, to get here. And the exact way you do it is you might want to write down a number like this. You can't remember exactly how that's done. See, here's a simple example. You notice that to do this one, you move it only one spot is 10 to the minus 1. So what if you have more spots? Then you just increase the number until everything works out. And that is how you do the scientific notation. So please do example 10 as part of your homework. So now let's go to page 34, where we look at example 11. Right? Did I get it right? Yeah, it's on the bottom. So 11, then now you have the scientific notation, and you want to know what that means. Then you have, for example, a number that is, let's look at part A. If you have example that's 3.5 whatever is 10 to the 14, then you move the decimal point 14 places. So we have 3.547, and then but you have to have that decimal point go 14 places. So we'll write a bunch of zeros here. I don't know how many. Okay, is that 14 yet? I hope so. Maybe, who knows? So we move this 14 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, okay, all the way here. So the decimal point has been moved 14 places, and therefore this is our answer. That's how you do this sort of thing. And then the other way is the same way. For example, we have the 7.91, right? But it's to the power 10 to the minus 7. That I'm looking at example part C. Now to do that, then what we're gonna do is write a bunch of zeros in front of it, because it's to the power negative. That means this number is very small. Do we have enough of them yet? Let's count, okay? Minus 7. So we need to move it 7 spots. 1, 2, 3, 4, 5, 6, 7. Perfect. So I'll write another 0 here. So the new number now is 0. Blah, 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 971. All right. So that's how you do the scientific notation. Basically, the 10 to the whatever power means how far you're going to move the decimal point, either to make it extremely small or to make it extremely big, depending on whether the 10th power is positive or negative. So please do example 11 as part of your homework. And then example 12, that's the same thing. But you have to do a little bit of addition. And once you've done that, then you adjust the decimal point until everything comes out. Yeah, okay. So please do example 12 as part of your homework. And also example 13. And that may come as 12 and 13. Now with that, we have come to the end of the section. For homework on page 37, please do problems 13, 19, 21, 23, 27, 29, 31, 33, 39, 41, 51, 53, 55, 57, and 59. Now that sounds like quite a bit of problems, but in this kind of section, that's really nothing. I mean, you really, when you get good at it, you should be able to charge through this stuff like in I don't know, a couple of minutes, seriously. Like really a few minutes to get through this stuff. If you do these and you're doing pretty good, then that's good enough. If you're having certain problems or can't do it very fast, see if you can pick a couple more odd problems. The odd ones have answers in the back, so you can check yourself. But maybe do a few more and to see if that you get any better. Now, if after doing some more you're just not getting any better, that's okay. Okay, as long as you've done your homework, you're are ready for the next class. The trick is to build the cheat sheet where you write down the stuff. Like this thing right here should be the cheat sheet in your cheat sheet for this section. Now, once you get your cheat sheet, then you can do it. And then algebra will be, what do they call it? Piece of cake? In the bag? Yeah, the algebra will be in the bag for you.